Guys, last week on Thursday, we talked about how to write system of equations. So we were given problems like the following, where you had to identify what your x variable would represent, what your y variable would represent, and then creating the two equations that would create the system. So that's what we did last week. This week, we're going to focus on graphing the equations that we get. So I'm just going to go ahead and give you guys a few different problems where you have the equations, two equations, and you're going to graph them to be able to identify their solutions. Now, keep in mind, as part of last week, we also discussed the three types of systems. So let me refer back to that real quickly because that's very important for you to understand. So when we're graphing it, if they intersect at a single point, then that means it's a one solution system. The important thing to keep in mind for one solution systems is that they're going to have different slopes. They have different slopes. They might have the same y-intercept, they might not. If they have the same y-intercept but they're different slopes, then the y-intercept is the point of intersection. But they're definitely going to have a different slope from each other. If it is a no solution problem, a no solution problem means it created those parallel lines because they have the exact same slope, meaning as one of them goes up and to the left, the other one goes up to the left the exact same amount. But they have different y-intercepts. They're going to cross the y-axis at a different point. And then we had infinitely many solutions. So for infinitely many solutions, they had the exact same slope and the exact same y-intercept, so that essentially it created the same line overlapping each other. So that means every single point on the line is considered to be a solution. And also as a reminder, how to graph your equations, you need to graph your y-intercept, and then you're going to use your slope as the direction. Remember, a positive slope goes up and to the right, or it goes down and to the left, because negative negative creates a positive. And then a negative slope means that it goes up and to the left, a positive over negative, or it goes down and to the right, a negative over a positive. So those will create those negative slopes. All right, with that in mind, let's go ahead and focus on graphing a few problems. So my very first problem, so I've printed off some graph paper here. My very first problem, I've got y is equal to 2/3 x plus 3. That's my first equation. And then I've got 3y is equal to 2x plus 15. Now, obviously, this one is in slope-intercept form. The second one is not in slope-intercept form. So you want to make sure that they're both in slope-intercept form when you're going to be graphing them. So in order to get this one in slope-intercept form, all I'd have to do is divide every single term by 3. And that's going to give me y is equal to 2/3 x plus 5. Y is equal to 2/3 x plus 5. All right, so the first thing I want to go ahead and do is identify the y-intercepts and then the slopes. So for my very first equation, I'm going to go ahead and we'll stick with doing this one in blue, and we'll do this one in pink. My first equation, the y-intercept happens to be at 0, 3, and the slope happens to be 2/3. So that means I'm going to go up 2 and then to the right 3, or down 2 and then to the left 3. I want to make sure I keep that in mind. For my second equation, my y-intercept is at 0, 5, different y-intercepts. My slope is at 2/3. Well, they're the exact same slope. And if I recall, when they're the exact same slope, but different y-intercepts, it means it's no solution. So technically, I don't have to graph this one if I don't want to. I already know that it's going to be no solution. But for all intents and purposes, I'm going to go ahead and graph it just so you guys can see. Again, it's up 2 to the right 3, or down 2 to the left 3. So we're going to go ahead and graph these just so you guys can see that they are going to be parallel lines. So I'm going to go ahead and draw my grid. So we'll start with the pink line first. The pink line had a y-intercept at 0, 3. So starting at my origin, I'm going to go up 1, 2, 3. So here's where my y-intercept is going to be at. And then I'm going to follow my directions, going up 2 to the right 3. 1, 2, 1, 2, 3. Up 1, 2, 1, 2, 3. I can even go down 2 and left 3. Down 2, left 3. Okay, and then that would go ahead and create a nice line here. Okay. All right, for my blue, the y-intercept is at 0, 5, which is located right here. But again, I'm going to go up 2 and to the right 3, up 2 to the right 3, or down 2 to the left 3, down 2 to the left 3. So you'll notice it's created those parallel lines. They will never touch. So this is one of those no solution problems. Okay, they had the same slope, right? We want to make note of that. Same slope, different y-intercept. Same slope, different y-intercept. It created that no solution problem. All right, let's go on to another one. Let's say for problem number 2, we have y is equal to 2x plus 1. And then our second equation, we have y is equal to 3x minus 6. Okay, so they're already in their slope-intercept form. I'm just going to go ahead and identify what the slope and y-intercepts are. The y-intercept for my first one is at 0, 1, and the slope is 2, which means that I can go up 2 to the right 1, or I'm going to go down 2 and then to the left 1. Okay? For my second equation, 0, negative 6, that minus 6 acts like it's a negative 6, is going to be my y-intercept. My slope is at 3, or 3 over 1, so that means that I'm going to go up 3 to the right 1, or down 3 and to the left 1. Okay, let's get that graphed. Draw a quick grid. Okay, for my first one, it's at 0, 1 is the y-intercept, and I'm going to go up 2 to the right 1, up 2, right 1, up 2, right 1, or down 2, left 1, down 2, left 1, down 2, left 1. Okay, and it's going to continue in that pattern. Excuse me. And then here we have a 0, negative 6. So that means I'm going to start at 0, go down down to the negative 6. Bless me, so sorry. And then I'm going to follow the pattern of going up 3 to the right 1, 2, 3, right 1, 1, 2, 3 to the right 1, 1, 2, 3 to the right 1, 1, 2, 3 to the right 1. Okay, and it does look like I'm going to wind up intersecting somewhere up here. So I might have to graph it even further up. So here I'm going to go up 2 to the right 1, up 2 to the right 1. I know I'm going into my work now. 1, 2, 3 to the right 1, 2, 3 to the right 1. Whew, good Lord, really having to go up into it. Oh, and here is where it's going to intersect at. Sorry, guys. Didn't mean to have to go all the way up into my work. All right. So if I connect it, as you can see, crossing through my work, I'm connecting it up to here. So this is the point that if I'm coming down, 1, 2, 3, 4, 5, 6, 7, then up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So my solution is going to be at the point 7, 15. And what this means is that if I plug in a 7 for the x and a 15 for the y, well, 2 times 7 plus 1 does equal 15. 2 times 7 is 14 plus 1 equals 15. Okay, then if I do 3 times 7 and subtract 6, 3 times 7 is 21 minus 6, it does equal 15. So the solution for both of them together is going to be 7, 15. All right, let's try another one. Sorry about that going all the way up. I promise the next one won't do that. All right, problem number 3. We got y is equal to x plus 3. Y is equal to negative 2x minus 3. Okay, they're already in slope-intercept form, so let me go ahead and identify my intercepts and my slopes. For the first one, we're at 0, 3. For the y-intercept, the slope is at a positive 1. That means it's going to go up 1, to the right 1, or down 1, to the left 1. Okay, line number 2, we have a y-intercept at 0, negative 3. And then we have a slope at negative 2. That means we are going to go up 2, but to the left 1, positive and negative, or down 2 and to the right 1, negative and a positive. Okay, let's go ahead and get that graphed. So obviously they are different y-intercepts and they are different slopes. So again, the first thing you always need to check, are the slopes the same? Slopes are different, so we know that there's definitely going to be one solution. If the slopes are the same, it's no solution. If the slopes and the y-intercepts are the same, then it's infinitely many. All right, graphing my first point, 0, 3. And I'm going to go up and to the right, up 1, right 1, up 1, right 1, up 1, right 1. Or down 1, left 1, down 1, left 1, down 1, left 1. So this is basically what the graph is going to look like. All right, for the next one, 0, negative 3. And I'm going to go up 2 to the left 1, up 2 to the left 1. And I'm going to intersect it, up 2 and to the left 1. So I can go ahead and stop right there because I'm going to intersect. Okay, so we've got this going here. This is our point of intersection. So that's our solution. And our solution is at negative 2, positive 1. All right, we're going to do one more example. One more example. Okay, problem number 4. So we have y minus 6 is equal to 2x. Y minus 6 is equal to 2x. And we've got y is equal to 2 times the quantity of x plus 1. And then outside the box, we've got plus 4. All right, so neither one of these are in slope-intercept form. Let's go ahead and focus on the first one. Getting this one in slope-intercept form is not too hard. All we have to do is get that y isolated by adding the 6 to both sides. Can't add a 6 to the 2x because they're not like terms, so we just have the equation y is equal to 2x plus 6. That gives me a 0, 6 for my y-intercept. And my slope is at a 2, which means I'm going to go up and to the right, up 2 to the right 1, or down and left, down 2 to the left 1. All right, second equation, this one, you have to do distributive property first and then combine like terms. So we're going to distribute 2 times x, which is 2x, and 2 times 1, which is a 2. But then you still have this plus 4 off to the side. You can combine that 2 and that 4 together, and that's going to give you y is equal to 2x plus 6. Oh, look at that. Identical equations, which means identical slopes and identical y-intercepts. So we know if it's identical, then that means that they are infinitely many solutions. But again, I want to just show it to you graphically so that you get that idea. Okay, so I'm just writing down what the slopes directions are for that one as well. Let's go ahead and graph it. Again, just so that you can have a proper idea of what it looks like. Okay, so if I graph the first point, 1, 2, 3, 4, 5, 6, and I'm going to go up 2 to the right one, or down 2 to the left one, down 2 to the left one, down 2 to the left one. Okay, connect them, and then same idea that I'd start overlapping, and everything would wind up being the same. Okay, so then our solution is infinitely many solutions. Infinitely many. All right. This concludes our lesson for today. You can go ahead and get started on your practice.